Hello, my name is Bowen Yu, and I'm going to present the solution to the problem GCD harmony. In this problem, we have a tree of up to 5,000 nodes. Each node has an integer value in between 1 and 100. You can modify any node's value to any positive integer of your choice. If you modify a node value to v, you will pay a cost of v. We'd like to determine the minimum total cost to modify the node values so that each pair of adjacent tree nodes have their values GCD greater than 1. In the first sample case, we can choose to modify 5 to 6, or we can choose to modify 5, 3, and 9, or to 2. Both solutions have a cost of 6. The key observations to solving this problem are the following. First, we can always modify all node values to 2 at a cost of 2n. Therefore, our answer will never exceed 10 to the 4th. Secondly, we will never choose a new node value that contains a prime factor that does not belong to any initial node value, except for 2. Because the initial node values are between 1 and 100, we will only need to consider 25 prime factors in this range. We will choose new node values that contain those prime factors. How many new node values are there in between 1 and 10 to the 4th that satisfy those requirements? There are 3,715. This is our new value space. We can formulate a dynamic programming approach based on our previous observations. Let's denote the subtree rooted at node x as Tx. If we want to make Tx GCD harmonic, and then give x a value of v. Let's denote the minimum cost to do so as gxv. Because x now has a value of v, every child y of x must have some value that works with v under the definition of GCD harmony. Let's denote fyv as the minimum total cost to modify ty so that ty itself is GCD harmonic, and then y has a value that works with v. Based on these definitions, we can see that gxv now equals to the sum of fyv, where y is a child of x, plus the cost of changing x value to v. After we computed gxt for every possible t, we will need to derive fxv from gxt. Let's consider each prime factor p that belongs to t. We will have hxp that equals to the minimum of gxt. This is the minimum total cost to make Tx GCD harmonic, plus we will have x value to contain a prime factor p. Now fxv can be derived from taking the minimum of hxp, where v is a multiple of p. These two steps can be computed in OV log v time, where v is the number of new values that we will consider. This count is 3,715. The total time complexity of the dynamic programming is going to be n times v log v.